I've read this in a few places and I've heard people say this. They say developers aren't paid to code. They're paid to solve problems. And I'm like, yeah, that's kind of true, right? But I mean, at the end of the day, you quite literally are paid to code. You could be a really good problem solver, by the way, if I really extend this example to the very ends, which I think is a good way to usually try to decide if an argument makes sense or not, is to look at the extreme cases on either end and see if they make sense. So, for example, someone says, you're paid to solve problems, not to code. You take that to an extreme and you think, then I don't have to code. And at the one extreme is somebody that's really good at solving problems, like generic problems. And then they have a computer in front of them, which requires them to write code to solve the problem. They can't solve the problem, can they? On the other end of the spectrum, you might have somebody that knows every syntax of every language, all the quirks and weird things about every language from C to Rust to Zig to all these weird things. They can't solve a problem. Do you see the issue here? You have to do both, right? Now, there is a pattern. There's a method to the madness. I'm on LeetCode, a site that I don't hate. I also don't spend a lot of time here, to be completely honest with you. I've done tons of interviews, by the way. I am obsessed with interviews somewhat because I stuck to them so much over the years. And I finally got pretty good at them, made it all the way to some of the biggest companies out there, and still failed at the final interviews. But I've also passed a ton of final interviews. I've interviewed tons of people. I do mock interviews all the time with people. I like the fun, the game of interviewing because I'm a little weird. I also know it's one of the highest paying skills you can have as a software developer or really in any profession. And I also know that solving problems through code is the highest paying skill because not only does it help you on the job, but it helps you in the interview. So I'm going to walk you through the process that I use, and I'm not guaranteeing that I'm going to solve this problem. I'm just going to walk you through the process that I use to solve problems with a problem that honestly I'm not really confident in, right? I don't like this problem. I kind of picked it because it makes me a little nervous. And maybe you're reading this problem and maybe you're familiar with it. You're like, oh, that's a simple problem. Then just skip the video. Like, don't get out of here, right? This is for people that want to know how to solve problems. And they might think, hey, maybe I know a little bit about solving problems. I do know a little tad bit about solving problems. So I'm going to just walk you through my process to do it. Not guaranteed I'm going to get the right answer. If that was the case, then we wouldn't need to have people writing programs in the first place, right? We wouldn't have hard problems. If every problem was solvable through some like step-by-step process, they wouldn't really be problems, would they? The world would just be a much easier, simpler place to understand. We wouldn't have world hunger or wars, people dying, right? We just solve these things. Not the case. Let's look at a microcosm of the world's problems by checking out this problem in LeetCode. Best time to buy and sell stock too. So we have an array, and we're going to walk through this problem really briefly. We have an array, and we can buy and sell the stock at any time. You can hold at most one share of at any time. You can buy and sell the stock on the same day. So you can buy and sell the stock as much as you want. We're supposed to return the max profit. And here's an example. So I'm going to try to understand this problem before I write a single line of code. In fact, coding is the last thing we're really going to do here. So I'm looking at this problem and I'm going to write it out too. I'm going to make some space for me to make some little scratch here. And I'm going to take this and I'm going to make sure I understand this problem because I see that 715364, these are stock prices. Cool. And you say you buy on day 2, which is 1. Okay. So if you buy on day 2, which is the price is 1, and you sell on day 3, the price is 5, and 5 minus 1 equals 4 because math. And then you buy on day 4, which is 3, and then you sell on this and you get 7. Okay. So the highest price you can get from this is 7. Okay. Okay. That seems, I guess, something reasonable. Let's take another example here. I'll be honest, I'm still kind of like, how do I do that? Because if I look at this just as a regular human, not thinking in the computer language here, I'm thinking if I just look at this, I'd say, oh, we're at 7. I probably wouldn't buy that day. It's the highest you can get. And I also know the future apparently in this pattern because I have all the future that I would know. So I would always think I buy low, I sell high. This is economics 101, right? You buy low, you sell high. So if I buy low, 7 is not low because I see, oh, the next day it's lower. So how did I know that I shouldn't buy day 7? Well, on day 1 at 7, I know because I look at the next day and I see it's lower. Okay, now how do I know when to sell? I look at the next day and I say, oh, it's higher than what I am right now, and I know to sell. Okay, oops. And then I go, okay, cool. Now I'm at 5 and think, okay, the next day is lower. I don't sell. Okay. And then I look at the next day and I say, oh, it goes from a low. So it goes from this valley to a peak, and I see that kind of thing happen. So 7 to 1 is a valley, 1 to 5 is a peak, 5 to 3 is a valley, 3 to 6 is a peak, 6 to 4 is a valley. Have I found the pattern? And just as a regular human, right? I'm looking at this, and that's the way I think. That's the way I mentally have this framed in my mind. Now, this is things that get a little interesting because the explanation here is that we get 4. So let's see if my logic holds up. So if I buy on day 1, I say, okay, we're at a peak 2, so that's 1, and I'm gonna write down under this what happens each day. So I go from 1 to 2, which is 1. I see another peak here. Okay, 2 to 3 is another peak, which is 1. 3 to 4 is another peak, which is 1. 4 to 5 is another peak, which is 1. It works. This is interesting. Okay, so I think I understand the problem here. Now let's look at this one too. So now we're going through a few cases. Okay, and we're doing this one as well. And it goes here like, well, you can't make any money. Okay, so we have valley. Okay, we have a valley from 7 to 6, valley from 6 to 4, 4 to 3, valley, 3 to 1, valley, none. I like this. Let me add something to this. What if I put 100 here? Well, then you should be able to make if you bought it one and sold it 100, then you'd make 101, right? You'd make, what would you make at this point? If you went from 1 to 100, you would make 99, right? So let's see if this works out still. Okay, valley, 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 peak 1 to 100, 99. What if I move the 1? So I like to keep breaking the problem or making it more difficult. So if I have 1 to 7, now this is where things get weird because you could technically 1 to 7 is a peak. So we say 1 to 7. Well, how much would you make there? 6. 7 to 6, no. 6 to 4, no. In 4 to 3, no. 3 to 100, yes. What's that? 3 to 100 would be what would that be? 97. So 97 plus 6 would be, what would that be in this case? That'd be 104 or something like that. I think I have enough information here to try to do this. I think that the pattern I have is going to hold. And what is that pattern exactly? And we're going to write this out in plain English. We're not going to worry about coding at all right now. Again, English is our primary coding language, and we have to look for what looks to be, is there a peak we've hit? And how do we define a peak? I think this is really important. How do we define what a peak is? When the previous day, when previous day is, so from 7 to 1, the previous day is higher. From 1 to 5, so I'm at 5, and I look at the previous day is lower. And is that it? Do I just have to look at the previous day is lower? Because in this case, what happens? We go to 7, we go to 1. We see is the previous day lower? Cool. Okay. Oh no, is the previous day lower? No, it's not. We go to 5, right? So we go to 5. We look at is the previous day lower? Yeah, it is. Okay. We go to 3. Is the previous day lower? No. We go to 6. Is the previous day lower? Yeah, it's 3. Oof, I like this. Okay. We always start at the next one. We have to look at the previous day. So we're always going to start ahead. So is 2 bigger than 1? Yeah. Okay. Is 3 bigger than 2? Yeah. Is 4 bigger than 3? Yeah. Is 5 bigger than 4? Yeah. All right. I think we have it. I think we have the answer here. So is there a peak we've hit? When the previous day is lower, then what? Then we add to the running total. Okay. Which starts at 0. All right. And I'm ready to try this out. I'm ready to see if this works. 4, let I equals 1. Why 1? Looking at the previous day. Is the previous day, right? I'm just going to put this down here just to translate our code into English. For let I equals 1, such that I is less than prices dot length. Okay. And we'll move that bad boy up there. Now we just check this. if we'll make this const current price equals prices at I, and we'll just do both. We'll look at the current price and the pre price, and we'll store them. I'm just doing this fancy thing. You don't have to do this if you don't want to. And we'll look at prices at I minus 1. That is the previous price. And then we'll just simply do some math, right? Like if the previous price, so if the previous price is less than the current price, well, we've hit a peak, right? And so then what we need to keep track of a total here. So we have a total equals 0. And I'm flying through this, so I wouldn't expect somebody. I mean, this part is actually trivial in my opinion. Like, if you do you need to watch me actually solve this to prove that it's right? I mean, who cares at this point? I think we have a pattern, obviously, and we figured out the pattern. The coding is just what I'd consider an implementation detail. But I think there's an important piece that's going to happen after I solve this, which I also want to show you. So once we solve this, it's not enough to just solve it. We want to solve it and understand why. Is there a pattern here? Is there something I found this pattern, but I'm sure there's a pattern here that somebody could use. Leak code problems generally lend themselves to patterns. So what do we do if the total? We say total plus equals the current price minus the previous price, I believe, because you take the current price, which in this case would be like 5, and you say what's in 5 minus 1 is 4. So we say total plus equals the current price minus the previous price. And then at the end, we return the total. Let's run it. Let's just run the code and see if it works. Kind of nervous. I always get nervous in this. Oh, come on. Oh, silly me. Look at that. I hope you caught that if you're watching this. Now let's see. It's even more intense now. Look at that. Look at that. Okay. Test cases work. Let's just submit this bad boy and let's see if it works. This works. Pretty happy, actually. Pretty nuts. Okay. Wow. This is pretty freaking nuts. So I just won the game. I beat you, LeetCode. Take that. Now, but I'm not done yet. We're not done just because we're done. That's silly, right? Why would we be done just because we're done? No, we're not done. What we want to do is pop this bad boy into ChatGPT. We say, hey, is there a pattern for this code I've written to solve a LeetCode problem regarding stocks and the best time to buy and sell? And we'll just dump it in there and let's see what it tells us. LeetCode again. I mean, ChatGPT is just going to give us the most basic generic answer, which is kind of what we want because this is not like some really novel problem. Okay, so yeah, this is what seems to be like a greedy approach. And if you're not familiar with greedy approaches for problems, it's where you're looking at like what is the best at the local area I'm in. So what is the most or least I can get in this tiny window? And which is exactly what we've done. It's kind of funny because until it said this, I honestly was like, wait, I know there's a pattern for this, but I couldn't think of the exact pattern. And just gave it to me. So this is really, really helpful actually, because now it's not just, I didn't just go on some logic that I had in my head somewhere. I learned about greedy approaches a long time ago, and I kind of forgot, the name for it when I saw the problem. I couldn't identify it immediately as an algorithm that requires a greedy approach, but this is what but then Chat GPT so kindly told me, hey, you're doing a greedy approach here. Cool. And if I could read this, I would, but I'm not going to. You check it out on your own and do it. So now I've not only walked through the code, I've written out how I'm going to solve it before I even touched any code. At that point, when we already had the logic, it was pretty simple to just write down the code at that point. It wasn't super, super difficult, right? So I hope that's helpful. You can use this approach from anything from system design at a high level to small problems like this to working in like React apps, whatever. I think the main takeaway here is to one, understand the problem, come up with solution in words in your primary coding language, which is English. And then once you have a satisfactory approach, then and only then do you sit down and write any code at all. Hope that's helpful. Screw you, LeetCode. Take that. I'll be back to solve more of these in the future, or maybe not. I don't know. I don't really like doing these on camera and solving problems. I think there's enough code content like this. So if you have an idea for what you'd like me to talk about or do, or something that would actually help you out as an early career developer, then let me know because I would love to make that kind of stuff for you. See you around.